Before we can connect the motor to a supply, we first need to do motor testing. This is done to ensure that the motor is safe for use and that it's not going to cause any electrical faults or fires. This process is called the commissioning. This can occur in two ways. First ways is electrical testing. Now when it comes to electrical testing, let's quickly look at the termination box of a motor. There we've got earth, U1, V1, W1, V2, W2, U2. Okay, now there's three tests that needs to be done. We have to remember that our coils for our stators are connected between those points over there. Now the first test that needs to be conducted is the continuity test. Okay, or the continuity of the windings. All these tests are done by means of megas, and basically what we're going to do is we're going to connect our mega over the V coil, over the W coil, and over the U coil. Now these three should each give us a very similar value. Okay, needs to give us a very similar value in order to make sure that these coils are not damaged and that they are pretty much balanced. The next test that needs to be conducted is the insulation resistance between the windings. So now we're going to take our mega and we're going to connect it between the first two coils, we're going to connect it to the second two coils, and we're going to connect it to the third two coils. Insulation resistance. Okay, and we should get greater or equal to 1 mega ohm for these tests. The function of this test is to make sure that these coils are not burnt, the insulation is not burnt, and they're not making contact inside the motor at this point in time. The final test that needs to be run is the earth resistance or the insulation resistance. Resistance to earth. Again, because it's an insulation resistance, it must be greater or equal to 1 mega ohm. And for this, we're going to connect our mega to earth on the one side, and then we're going to connect to coil W, coil V, and coil U, which then should all give us 1 mega ohm or more to make sure that the test, or make sure that the coils are not accidentally connected to the earth winding. All these tests must be conducted at least 1.5 times of the typical operating voltage that it's going to be experiencing. So if we look at our 3-phase motor, if we're going to have it experience a 240 volt supply, that's a typical operating voltage, then we need to test it at least 1.5 times that, which means 360 volts is what our mega is going to be set at least. The mechanical testing, we are looking at physical aspects of the motor. That could include the rotor to make sure that it's the lamination of the core, the end plates are all nicely covered and conducted. The shaft mustn't be bent. The bearings must run free. They can be lubricated. The keyway is the master switch to the motor. The termination box, all wiring must be connected properly, and then the motor frame must be clean, dust free, and there must be no cracks in it. The foot mount forms part of the motor frame, needs to be fastened properly. The front and back shields to cover the moving parts must be installed properly. Cooling fins, if there are any, must be clean and fastened securely, and all mounting bolts and screws must also be fastened correctly. When it comes to fault finding, we always use a voltmeter to determine if the motor terminals have a supply. If there is a supply but the motor is not running, then we disconnect the motor or the load from the motor and we try restarting it. If that doesn't work, then we need to disconnect the motor completely and run a commission test on the motor using a mega again. Again, part of the test includes all the mechanical inspections. Commissioning is the electrical test that we do on a motor before we connect it into a control circuit or onto a supply to ensure that it is safe and that we can certify that it is safe for use and that it is not going to cause any hazards.